All right, we're on page 4, number 19 here, working with some rational expressions. The first question is a solve. So all the questions we've worked before have been expressions. We did simplify, add, subtract, multiply, and divide. Now we're doing solve, which means we're working with equations. To solve an equation with rational expressions in it, we first clear the denominators. So to do that, we have to multiply times the least common multiple of all these denominators. So our least common multiple has to have an x in it. It has to have a 2 in it and an x. So far we have a 2 and an x. And the 6 is 2 times 3. So we're going to have a 2, a 3, and an x, and that makes 6x. We're going to multiply the entire equation times 6x, and we're going to use over 1 for this because you don't have to do the denominators. You're only going to do the numerators. Now when you do this, it's top times top, bottom times bottom, every term, all 3 terms here. So the first one is going to be 6x times 2 is 12x. And in the denominator, 1 times x is x, plus 6x times 1 over 1 times 2x equals 6x times 5 is 30x over 1 times 6. And now we're going to reduce them. So when you look at each one, you're looking for what you can reduce. And in this term, we can reduce the x's, so that makes 12 plus, all right, these x's reduce. 6 divided by 2 is 3, so this becomes a 3 equals, all right, this x isn't going to reduce since there's not 1 in the denominator, but we do know that 30 divided by 6 is 5, so this becomes 5x. Now we have a really simple equation that I'm going to carry on over here, and we're going to go ahead and solve. 12 plus 3, these are like terms, makes 15 equals 5x. To isolate this x, we divide by 5, so we have x equals 3. Number 20 is the same type of question with irrational expressions, the only difference being that this is one rational equal to another rational, and it looks like it is actually a proportion. When you have a fraction equal to another fraction, it's a proportion, and you can get rid of the denominators by simply cross-multiplying. In other words, this times this will equal this times this. So that's what we're going to do first. We're going to do 2x, I'm going to write this out, 2x times x plus 3 will equal x plus 1 times 2x minus 1. So to solve for this x, we first need to do some simplify. So we're going to distribute. We're going to do double distribute or FOIL over here and see what we get. So 2x times x makes 6x squared. 2x times 3 makes 6x. I made a mistake. This is not 6x squared. It's 2x squared. There we go. Equals. All right. I'm hoping you guys remember the double distribute slash FOIL multiplication here. This should become 2x squared minus x plus 2x minus 1. So we have 2x squared plus 6x. You can't put those together because they're not like terms. Over here we do have some like terms. So we have 2x squared plus x minus 1. All right, now to finish this, I'm just going to scroll up a little bit here. I hope that you recognize these 2x squareds when you try to combine them, because they are like terms, they're going to cancel each other. You subtract 2x here, subtract 2x here, they actually end up canceling each other off. So what you really have is 6x equals 1x minus 1. So this 1x needs to join over here with the 6x. So when we do that, we subtract an x, we end up with 5x equals -1. And we need to divide by 5 to isolate that x. So x equals -1/5. On 21, same type of question. It's still a rational equation here. We've got all these fractions, but the common denominator is not going to be hard here because we have a denominator of y plus 1. So we just need to multiply the entire equation by y plus 1. And you can put it over 1 if it helps you. You're just going to multiply y plus 1, numerator and denominator. But when you do this, you should notice that these y plus 1s will cancel. Every single one of these y plus 1s are going to cancel. So when we do that, we end up with 5 plus 2 equals, all right, be careful because this 3 does not have a y plus 1 in the denominator to cancel with the y plus 1. So we need to keep the 3 times y plus 1. But in this term, the y plus 1 will cancel, and we have a 10. So just going through combining some like terms here, we have 7 equals, we're going to distribute this, 3y plus 3 plus 10. And I can keep the y on this side. Let's just keep continuing. Combine some like terms here. This is 13. Then I want to subtract 13 to join it with a 7 over here. So this will be -6 equals 3y. And then divide by 3. Nicely, this fraction reduces for us. And we end up with -2 equals y. Or y equals -2. Okay, number 22 looks like it's a word problem. So let's see the whole thing here. If it takes Sam 3 hours to wax the floor and Bob 5 hours to wax the same floor, how long will it take Sam and Bob to wax the floor if they work together? Okay, so we're going to write a little equation here, just like we practiced in class. Sam's time. If it takes Sam 3 hours to wax the entire floor, he can do 1/3 of the floor in 1 hour. If it takes Bob 5 hours to wax the floor, he can do 1/5 of the floor in 1 hour. And that will equal the reciprocal of their total time, or 1/t. Now, to solve this, we're going to clear the fractions by multiplying times. 3, 5, t have a common have a least common multiple of 15t. So everything times 15t, and you can put it over 1 if it helps you. You're going to distribute this, and you're going to have 15t over 3 plus 15t over 5 equals 15t over t. And now we can reduce those fractions. That gives us 15t over 3 will give us 5t. Plus 15t over 5 will give us 3t. Equals 15t over t. Now these t's cancel, so we just have 15. So just combining some like terms here, we have 8t equals 15. Isolate that t. We get t equals 15 over 8. Well, of course, if we're talking about hours, that doesn't really make sense. So we're going to change it to a mixed number. 15 over 8 is 1 7/8. So don't forget, you're answering these questions in a complete sentence. How long will it take Sam and Bob to wax the floor if they work together? In a complete sentence, let's see, it will take them 1 7/8 hours to wax the floor together. Don't forget, you're always answering your word problems in a complete sentence. All right, number 23. This is a literal equation, which means that sometimes it's a formula, but some kind of equation that has more than one variable in it, and you're being asked to isolate a specific variable. So in this equation, we're being asked to isolate C. So there are 4 steps here, the first of which is to clear the fractions. So looking at the denominator, there's only one denominator here, C. So we just need to multiply everything through by C. Multiply everything by C, and that's just distribute there. That will give us AC equals, when you multiply this term times C, the C's cancel. So it'll be B plus, and C times 1 is C. All right, so that's clearing the fractions. The second step is to put all the terms with the variable you're trying to isolate on one side. So those 2 terms with the C need to be on the same side. We will do that by subtracting C from both sides. Now be careful, because on this side, these are not like terms. So this turns into AC minus C equals B because they're gone here. Now you just have to factor out your variable. We're looking for C. It's a GCF on this side now. So factor out C. You're left with A minus 1. And then you can just divide both sides by A minus 1. And you have isolated your C. We have C equals B over A minus 1. Number 24 is another literal equation, but this is a little bit easier because it doesn't have any pluses or minuses, so you can treat this like a proportion. If you just put this as f over 1, we talked about this earlier, with the proportions, this will equal this. So we really have FR, F times R, equals mv squared times 1, which is just mv squared. We're trying to isolate this R, so all we need to do is divide off the F here. And we have R equals mv squared over F. Now, this method using the proportions only works if you have a fraction equal to another fraction. If there are any pluses or minuses, it won't work, and that's why we couldn't use it up here, because we have this plus term over here, so it wouldn't have worked here. We have to go through those steps with the factoring and all that when we have the pluses. But if you just have the proportions like this, you can just do the cross multiply and then divide off what you don't need.